Hello, welcome to Math 103. This is the lecture on section 2.7, absolute value equations and inequalities. The absolute value bars, the absolute value of a number, is probably recognized by most of us. In number 1 here, we have the absolute value of x equals 6. So we're thinking about the solutions there, the values that we could plug in for the x to make that a true statement. And I think most of us recognize, that's either going to be x equals 6, or there is another solution, right? Because if we put a negative 6 right there in place of x, you do the absolute value of negative 6, that would also give us a true statement. So in this case, the solutions are x equals 6, or we could also have x equals negative 6. So there are two solutions. Make note of that. Looking at number 2, though, the absolute value of x plus 3 equals 7. Well, the numbers aren't as nice and neat there as the number 1s were, but let's think about this. Obviously, x plus 3, the absolute value equals 7. We could plug in x to be 4. But there is another one. You might think about that, but if I substituted a negative 10 in for the x, that would give me a negative 10 plus 3. That would be the absolute value of negative 7. And absolute value, that you get positive 7. So yeah, we could also have there a solution of x is negative 10. Now, having said that, here's what I'd like for us to notice. There are two solutions. One is x is 4, the other is x equals negative 10. So it won't always be a number and then the negative of that number. It's however they work out. And here's how they work out. If you'll notice here, let me write two equations right here to this side. Let's say x plus 3 equals 7, or also x plus 3 equals negative 7. Let's notice something about that. If we solve those two equations, two separate equations, notice what we get. Subtract 3 on this first one here, we got x is 4. Alright, well that looks familiar. And then subtract 3 over here on the second one, and we've got x is negative 10. Hey, how about that? We got x is negative 10, we got x is 4. That's exactly what we had over here. So when solving a absolute value equation, there's two equations that you're going to solve. You're going to solve the x plus 3 equals 7, that is the expression inside the absolute value equals 7, so it's just like taking out the absolute values. But then we're also going to solve the expression in the absolute value, x plus 3, and set it equal to a negative 7. So that's what it's going to be all about in solving absolute value equations. Let's look at another one here then and use that system right there. Alright, so as they get more complicated, this one's 2x minus 5 equals 13. Well, we saw there's going to be two equations that we're going to need to write. And remember what they were. The first one was just set the expression equal to just the number that it equals. And so 2x minus 5, we're just going to set that equal to 13. And then the other one, if we look back at the other one, that's setting the expression equal to the negative of that number we have on the right side there. So it's going to be 2x minus 5 equal negative 13. We solve those two equations there. That's going to give us our two answers here. So we solve this one. You add the 5, so we have 2x equals 18. Divide by the 2, and we've got x equals 9. On the other side, though, we've got x, 2x minus 5, so we add 5 again. and so that'll get us 2x. Now negative 13 plus 5 is a negative 8, and we divide off the 2, and we've got x equal negative 4. So our two answers are a 9 and negative 4. And you can check those and make sure, but those two will solve the equation. So there's the original equation. There's going to be two answers to these absolute value equations that we saw. Let's look at a couple of others with a little bit of a twist on them. We want to solve 3x plus 7, the absolute value, minus 4 on the outside equals 2. Well, this one has the, of course, the complication of we have something outside the absolute values on the left side. Need to figure out what we're going to do with that. Well, it turns out we don't want to do our two equations yet, 2 equal 2 and then the equal negative 2. Yeah, that technique works only if we have the absolute value isolated. So we need to isolate that absolute value. That just means get the absolute value on the side by itself. So before we can make the two equations there, we got to isolate. So how will we do that? Well, we need to get rid of this 4, move that 4 to the other side. Well, it's minus 4, so if I add 4 to both sides, that's going to get me this, 3x plus 7, the absolute value, equals 6. Negative 4 plus 4, that's 0, and 2 plus 4, that's our 6. Alright, so yes, we have now a scenario where we can set this equation up into two separate equations. So we're going to go with the 3x plus 7 equals 6, and we're also going to do 3x plus 7 equal negative 6. Solve those two equations out, and we will have our solutions. Alright, we start over on this one. So 3x plus 7, we're going to subtract the 7, and so that'll give us a 3x equals negative 1, and then divide by 3, and we get nicely x equals a negative 1/3. Over here on the second one, we've got to subtract 7 again. Well, that's going to be 3x equals negative 13. Divide by 3, and we have x equals a negative 13/3. Or you can write that as a mixed number, negative 4 1/3. I'm going to leave it negative 13/3. All right. Now the fifth one here, the absolute value equations, well, this one has the complication that we've got the absolute value on both sides. What do we do there? Well, we're going to follow about the same guidelines. I'm going to set up two equations. I'm going to say my 2t minus 9 equals, and then I'm going to do something with the 3t plus 7. Well, in the first case, I'm just going to say, well, let's try 3t plus 7. So just basically getting rid of the absolute values. Now in the second equation, 2t minus 9, well, I need to do the negative, right, of the second, for the second equation, I need to do the negative of the 3t plus 7. Well, let's write that this way. The negative of 3t plus 7. Now I write that because that way because yeah, I'm gonna have to do a little distributing of my negative, but we'll get to that momentarily. All right, let's solve these two equations. So we add 9. So we have 2t on the left equals 3t plus 16. Now I need the t's on the same side, so I'm going to subtract 3t from both sides. So that'll get me a negative 1t equals 16, and then all I have to do is divide by negative 1. T equals negative 16. Solution 1. Solution 2 over here, well, like I said, we're going to have to distribute our negative there on the right. So that's 2t minus 9 equals negative 3t minus 7. Negative times 3t is negative 3t. Negative 1 times 7 is negative 7. Now we need to get the variables on one side, constants on the other, so I'm going to add 3t, and I'm going to add 9 to do that. Alright, so that'll get me 3t plus 2t is 5t, negative 7 plus 9 equals 2. Divide by 5, and t equal 2/5 is the second solution. Alright, so that takes care of our absolute value equations.